we are discussing on the finite state machine design. Actually, the last day we are in the halfway of explaining one example, the word problem, the pattern recognizer. So, today we will learn the state machine design and optimization. Now, the last day of the problem we are discussing, that was the how the FSM can be designed for a word problem. See, the problem is a problem defined in some high level language, say English language, and first we map it to a formal specification. The example we took, it is a pattern recognizer. We defined that pattern recognizer is a sequential system whose binary output at time t corresponds to the particular pattern recognized by the system. Now, we take one example, say a finite string recognizer has one input and one output. The output is asserted, that means output will be 1 whenever the input sequence say 0 1 0 has been identified. So, my pattern recognized is 0 1 0, and another condition we have imposed, that as long as the sequence 1 0 0 has never been seen, means if one string 1 0 0 is reached, then this condition is no more valid. So, if we take one example, so this is my input string. So, 0 0, if 0 comes, then output is 0, input 0, output 0, 1, that means string is 0 0 1, output 0. Now, when one 0 arrives, that means 1 0 1 0 string has identified. So, the output is 1. Now, again input is 1. So, 1 0 1, output is 0, 1 0 has reached, again 0 1 0 is identified. So, output is 1. So, in this way again 0 1 0, output is 1. In this way it will proceed. So, this is the we understand the problem statement. Now, we first draw the state diagram. So, first this is the initial state. As last day I mentioned the design process, then we need one starting state or initial state. Say initial state. Then if it is if a 0 has reached, then it will be a new state. If a 1 has come, that means always, because it is a one input machine. So, either 0 or 1 can come. If it 0 comes, it is S1, if a 1 comes, then it is S4. Similarly, that again if it is a 0 comes, then it is a another line 0 0, and see this is the output, means when one 0 comes, output will be 0, another 0 comes, output will be 0. Now, if a 0 1 0, so 0, say this output is 1, means this should be a 0 input, 1 input, then 0 input. So, if a 0 1 0 is identified, then only the output is 1. But if it is a 1 and say 1 0, we know that for any other string other than 0 1 0, any other string 0 0 0, 0 0 1, 0 0 1 1, any other string 1 0 0, 1 0 1, 1 1 0, 1 1 1. For remaining 7, it will be a 0 output. So, mainly this is the 0 output state. So, this is the first stage or the first step of the state diagram. Now, another condition was there, that if a 100 is recognized, then this condition is no more valid. So, that is why that 100 has been seen. So, what will be the next step? Now, draw state diagrams for the strings that must be recognized, that is 0 1 0 and 1 0 0. So, already we have seen that 0, that means this is my 0, okay. This is my 0 1 0 and this is a 1 0 0 state. Okay. This can be 0 or 1. So, it will be in the some graveyard state, it will be there. Now, exit condition from state S3 have recognized 0 1 0 if next input is 0. So, already we have seen that if it is a 0 1 0, then it will be a output. This is the output 1, output 1 output will be 1. Now, if another 0 has come, say 0 1 0 and 1 0. So, 0 1 0. Now, if it is a 0, if it is a, say first we take 1, say 1 0 1 0 has come, then it is output will be 1. This is the output. Now, say if 1 again 1 has come, then there are chances that the next can be a 0. That means, here 1 0 1 0 string is identified, here can be 1 0 1 0 string can be identified. So, here it can be 1. So, if it is a 1, then it again returns to S2 state, because this 0 state. So, actually this 0 state is the this 0 1. So, 0 1 0 it will be looping again, because here it can be like that 0 1 0 again 1 0. So, that S2 and S3 it will be S2 and S3. This is the situation. Now, if a 0 has reached, because if 1 is 1 comes, then okay, every time it will be giving a 1 output, and 0 1 0 0 1 0, these loops will be in between S2 and S3. Now, if a 0 has come, then it should be 0 output, because if my input string is 0 1 0, now if 1 0 has come, then here it is a 1 output, but here it should be a 0 output. So, then it goes to S6 state, because S6 state we are seeing that this is a 0 output. So, it goes to 0 output. Now, we see the exit condition from S1. It recognizes strings of form 0 and no 1 seen, means see this the S0 was my initial state, okay. S0 is my initial state. So, initially that some 1 0 can come or 1 can come. So, actually if we see that, see this is my S0 state. Now, if 1 0 input has reached, then it will be going to S1, and if a 1 has come, say this is S2. Now, similarly here also some 0 can come, here also can 1 can come. Then if it is a 0, every time it is giving 0 output, 0. Then if it is a S3, then because 0 0 string is identified, again 0 output. Here say 0 1, say this is S4, again it is a 0 output. Now here it is a, say again it should be again 2 children, S5 and S6, again it can be 0, it can be 1. So this can be S7, S8, again 0, 1. Say in this way it will S11, S12, S13, say S14. So 0, then 1, then 1 0 input has come, then 1, then 0 1 input has come, then 1. Now see that here the input string is, if I consider S0, S1, S3, S7 or S0, S1, this transition if we consider S0, S1, S3, S7, then actually 1 0 0 0 input string is identified, 0 0 pattern is identified. So the output will be 0. Now if S0, S1, S3, S8, okay, so this is S0, S1, S3, S8. If this is a S8, this is a S8, then 0, S0, S1, S3, S8. So 0 0 1. So the pattern identified is 0 0 1. Output will be 0. Now if it is similarly, if it is S0, S1, S4, S9, now see 1 0 has come, then 1 1, then again 1 0. So if it is S0, S1, S4, S9, if it is S0, S1, S4, S9, this transition, then 1 0 1 0, that string will be identified. So the string identified is 0 1 0, and our problem tells that if this pattern is recognized, 0 1 0 is reached in the input line, then output will be 0. So then my output will be 1. If 0 1 0 is identified, then output will be 1. Remaining cases output will be 0. So here 1 output, this is 0 1 0, this is my 1 output. See now similarly if we see the other branches, then S0, S1, S4, S10 means 0 1 1. Then if in this branch it should be 1 0 0, output will be 0, 1 0 1, output will be 0, 1 1 0, output will be 0, 1 1 1, output will be 0. So if we consider this, if we consider only the current 3 inputs, then only this is the branch where I can get a 1. This is the branch where I can get a 1 output, and the remaining branches will give the 0 output. So the same thing we have identified here, that see the S0 is the initial state. If 1 0 has come, then it is S1. Now again 1 0 has come, 0 may come, may reach, then again it will be in the same state, because that if it is 0 comes, then output will be, this output will be 0, output 0. So S1 recognizes 0 0 0 this type of input string. Now only one shift will be there when 1 comes. So now it will be, a transition will occur from S1 to S2. So this is a, but the string identified is 0 1. So again output is 0. So here output is 0. Now again if the 0 comes, then only the output is 1. Now if a 1 comes, then again it will go back to, returns back to S2 state. If it is a 0, then it will go to the transition from S3 to S6. If we now see the other branches, that means when the transition occurs from S0 to S4, if one input arrives, then this 1 comes, output will be 0. Now similarly, just like the S1, S4 identifies that all one string, that means if a 1 comes, then it will recognize a 1 string. So S4 state is the all one string. Similarly, that S1 recognizes all 0 string. Now if it is if a 0 comes, so output will be 0. Now if a 0 comes, then one state transition occurs from S4 to S5. Now see, there can be another 1, and we know that if it is a 1, then also 1 0 1, then it is a 1 0 1, output will be 0, and if it is a 0 also, then also the output will be 0. So if it is 0 or 1, that it will be in the S6 state, and the output is 0. The output is 0. So S2 S5 with incomplete transitions. Why? That S2 is a 0 1 state. We have seen that again if we see the previous state, that actually 0 1 again 0, that means here if it is a input is string 0, then if it is 1 comes, then it will go to S2, then 0. So that 0 1 0, now again 1. So S2 S3, this transition is actually 0 1. It identifies the string 0 1. And see if it is S5, if it is S5, then actually 1 0. So that is written that S2 0 1, if next input is 1, then string could be prefix 0 1 1. So output will be 0 0, and S4 handles just this case, and S5 is the reverse one, because it is a 1 branch, and then if 0 comes, then only the state transition occurs. Then if it is a 1 0, then it can be 1 0 1 or 1 0 0. So if it is a 1 0 0, we know that is our, if it is a 1 0 0, that is our terminating condition. Terminating means that the pattern recognition case, that will no more valid. So this is the termination condition. Okay. So, 1 0 0 can be identified. So, if we consider now the final design, see this is our initial state S 0 0 S 0. So, we start from there. See, now if a 0 comes, it will go to the left branch S 1. Now, already we have seen that if now after reaching into S 1, the output will be 0, and number of strings that contains 0, that means for every 0 it will be in the same state S 1 and output will be 0. So, S 1 recognizes all 0 strings. Now, if a 1 comes, so now if a 1 comes, then only it will be a transition S 1 to S 2. If a 0 comes, then it is a, now if a 1 come, then what type of, so because we have already seen that every state there can be 2 input, either 0 or 1. So, now the present input is present state is S 2, and that is some strings of zeros and then 1. Now, it can be either 0 or it can be 1. So, there are 2 branches. Now, if it is a 0, then already we have seen that is our recognized pattern 0 1 0. But if it is a 1, then I want that should be a 0 1 1 case, and we know as it is 1 1, already we have seen that actually our S 4 recognizes all 1 1 string. So, that is why we redirect when 1 comes, that state transition will be from S 2 to S 4, because in the S 2 state has been reached after getting a 1, after getting a 1 input. So, it was a sum 0 0 0 string 1. Now, if a 1 comes, then it will be actually 1 1 string, and that is already we have identified that state is the S 4. S 4 recognizes all 1 or more than 1 input string. So, that is why it transitions or it goes to S 2 to S 4. Now, this is the S 3 is the condition. So, the 0 branches, or if it is now if it is in S 3, so already we have seen S 3 is our recognized input. Now, if a 0 comes, so output will be 0. So, it transitions from S 3 to S 6, because the string is 0 1 0 0. So, it is a 1 0 0, actually it is a 1 0 0 state. So, we see whether it is a 1 0 0 state or not. So, from the initial state again we start. 1 means it goes to S 2 to S 4, 1 input means S 2 to S 4. Then any number of 1 we have seen that S 4. So, if a 0 comes, so actually that is S 4 to S 5. Now, it is again if a 0 comes, then it is a S 5 to S 6. So, actually our S 6 state recognizes, if 3 input we consider 3 consecutive input bits, then actually S 6 is 1 0 0. That is why from S 3, when the present state is S 3, means S 3 recognizes 0 1 0. Now, if a 0 comes, so if we consider 3 consecutive input bits, then it will be 1 0 0, which is recognized by the state S 6. That is why S 3 to S 6 transition has been occurred. Now, if S 5 is in the state S 5, 1 1 has come. Now, see S5 means this is a 1 1, say S4 means any number of 1, now it is a 0. So, if it is a 1 comes, then it is a 101 state, it is a 101 state. So, it will go to the S2 state, because it is a, again if we start, this is a 01 state. So, that is why it is, because again it can 10 can come. So, S5 to S2 transition occurs. So, these are my final this is the final design of the pattern recognizer. So, now if we summarize the full design process, what we have done? First, we wrote down the sample inputs outputs to understand the specification. For the pattern recognizer, we have written that for what input patterns it will give a output 1 and remaining inputs output will be 0. Then we have done the state transitions of the sequences to be recognized. Say for this particular example, it is giving one output for only one particular input patterns. Now, there can be the cases, there can be some problem for which say more than one input bit patterns, the output will be 1. Say for 0 1 0 as well as for 1 1 1, the machine should give a 1 output. So, we do the state transitions. Now, add missing transitions, so that reuse states as much as possible, and then verify the I/O behavior of your state diagram to ensure if functions is actually are for the specifications. So, now what we have seen that last example, we have seen that there are 7 states we have drawn, because it is a 3 input pattern should be recognized 0 1 0, that is why we have given the 7 states we have taken. Now, if we see the full FSM design procedure, what we will be doing? The first we should understand the problem, then a formal description, then minimize the number of states, because ultimately our aim is to design or is to make a efficient design. So, we will not keep too many states, because if a number of states are more, then more flip flops will be needed, because already we have seen that if it is a n number of states, then log n number of flip flops will be needed for that. And then encode the states. This is for that encoding state encoding. Then choose flip flops, which flip flop we want to utilize for particular application, and then implement the FSM. So, now we will see the minimization. Again we consider the example, the last day we discussed the odd parity checker. So, that means one input pattern, if the number of ones are odd, then it will give a 1 output, and otherwise it will be 0. So, there are, what we have seen, there are 2 alternative state diagram. See that if initial state is S0, then if 0 input has come, any number of 0 means it will be a even parity, because no 1 is there. Now, if 1 comes, then actually it will be a odd parity, giving output 1. Then again if it is 0 comes, any number of 0, actually it will be a odd parity, so it remains in the same state. If it is 1 comes, then 1 plus 1, again it will be even parity. Now if we see that if we use 3 states, then again S0 is the initial state, any number of 0 it will remain in S0. Now if a 1 come, then it will be in S1. Now again if a 1 come, it should be in S2, output should be 0 because even parity. Now again any number of 0 will create that even parity, so it will be in the S2 giving 0 output. And so if it is in the 0, now if it is in 0 comes, then it will go back to the 0 state. Now see that identical output behavior on all input strings. So here there are 2 states, here the same problem we have specified using 3 states. So the state transition diagram we have made using 2 states and using 3 states, and they are behaving likely. So which one will be choosing? See, now the implementation will be different because here it is a 2 states are there, so we need only one flip flop, 0 and 1 state. Here it is a 3 flip flop, so at least we need 2 flip flop, 3 states we need 2 flip flop. That if we do the state encoding, that then 0 0 0 1 1 0 or 1 1, any one of these will be taking. See, so the implementation of these 2 state transitions will be different, but they are solving, both are solving the same problem, giving the same output. Now which one we will choose? So this is the main problem of the state reduction. So the main motivation is the implement FSM with lowest possible states, so that we get the lowest number of or least number of flip flops. So as much as possible, or smallest number of possible. Now lower number of states usually leads to more opportunities for don't cares. When we will be doing the design, we will take care of this thing, and reduction of number of gates provides efficient implementation. So not only the state, but also if we can reduce the number of gates needed to implement the design, then it will also provide a efficient design. So these are the main motivation for the FSM state reduction. So identify and combine states that have equivalent behavior. See, first what we are doing? We are considering all possible cases. If all possible input string comes, then what will be the output, or how the machine behaves? Means for all possible inputs, first we define all possible output. Then we try to identify and combine states that have equivalent behavior. See, in the last example, we have seen that whenever the S0 was all 0 strings, then from other present state, if it is a all 0 type of string arrives, immediately the state transition occurs from other state to the S1 state. We have seen that in our pattern recognition or pattern recognizer FSMs. So, now what do we mean by equivalent states? Say for all input combinations, state transitions to the same equivalent states. That means that if the state transitions occurs to the same equivalent state or same state for all input combinations, then we are defining these or we are naming these as the equivalent states. So, say for odd parity checker, S0, S2 are equivalent states because both output S0, both transition to S1 on a 1 and self loop on a 0. We check. So, see here S0 and S2. So, here S0, if one 0 input has come, that means when my present state is S0, present state it is S0. Now, if a 0 comes, if a 0 arrives, then again it will be in the S0, that means S0 to S0. Now, if a 1 comes, then it is a S0 to S1. So, if it is a 0 comes, then it is, say it is S0, and if it is a 1 comes, then it is S0 to S1 for S0 state. If we consider the S2 state, S2, say if a 0 comes, then again it is S2 to S2 if a 0 comes. If a 1 comes, then it is S2 to S1. Now, see, for all possible input combinations, means 0 and 1, that S0 remains in S0, S2 remains in S2, and for 1 S0 to S1, S2 to S1. So, that means for all possible input combinations, the state transitions of S0 and S2 are same. So, S0 and S2 are equivalent states. So, for both output is 0, both transition S1 and a self loop on a 0. So, S0 and S2 are equivalent state. Now, there are several algorithms exist for the state reduction. So, what should be the algorithmic steps? So, if we start with the state transition table, first we have defined for all possible inputs what should be the output of the machine. Then identify states with same output behavior. So, first what we are doing, that the states we are identifying which are giving the same output. Now, if such state transition to the same next state, they are equivalent. Just now we have seen that if the state transitions are also same, that means for all input combinations, if the state transitions are also same, giving the same output, then they are equivalent states. So, we identify here, thing is we identify the equivalent states. So, that what we intuitively what we understand, that the equivalent states can be merged, they are equivalent states. Now, combine into a single new renamed state. That means, these equivalent states when merged, they are giving a new state. So, repeat until no new states are combined. Now, we will follow these rules until we get any new two states can be combined. That means, we can't identify any equivalent states no more. Then we will stop. So, one very simple algorithm, and just from common sense it appears, that is the row matching method. So, if we see that again that odd parity checker, see that this is the input sequences and present state, and the all possible inputs we get. Then first is that input sequence. If reset, then the present state is S0, as always we are seeing. Now, if it is x equal to 0, it goes to S1, if it x equal to 1, it goes to S2. So, actually these are the inputs, and these are my outputs. Outputs are 0. Now, if it is now input sequence, these are next state for these inputs. So, I should write these are the next states. These are the next states for these inputs. So, now if the present state is S1 and input sequence 0 comes, then it will goes to S1 to S3. Similarly, if a 1 comes, then it will be S4. Now, if it is a S2, x equal to 0, it will go to x5, then it will be in S2 to S6, and in each of the cases it will give a 0 output. Now, in this way, if we consider the all 3 input patterns, then we will be seeing that from 0 to that for 0 state, or only for one input sequence, 1 bit input sequence, there are 2 states. Okay. So, if we see that for reset 1 state, for 2 input or 1 input sequence, there are 2 states, 0 or 1. For if we consider 2 bit input sequence, then 2 square means 4 state. If we consider 3 input bit sequence, then 2 to the power 3, 8. So, it will be total 15 such states will be there. That is why it is that 0, 1, 0, 0. So, here it is 1 state, here it is 2 state, here it is 4 state, and these are my 8 states. So, 1 plus 2 plus 4 plus 8, for all these the tables are completed. That means, this is the table that for all possible input sequences what will be the present state, what will be the next state for this particular input if this particular input arrives, and then what will be the output. So, this is my table. Now, we try to find out whether any row matches. That is why it is a row matching algorithm. So, see that if we consider that row, now what do we want to match? We want to match that if the present state or what are the different present states which gives the same output and same state transitions. So, here if we see, you check all the rows, then we will be seeing that here it is a, see this is for this state, that means when the input sequence is 0 1 0 0 1 1, present state is S10, and for the next state x equal to 0, the next state is S0, for x equal to 1, the next state is S0, output is 1 and 0. Similarly, for 101, when the present state is S12, then also the next state will be S0 S0, giving the output 1 0. So, these two rows are giving the same state transitions. So, these two rows can be combined. Now, see these two rows 0 1 1 or 1 0 1 can be combined, and as the next states are S0 S0, so it is, and this is a new present state S10 dash. So, this is S10 dash, the new renamed state. Now, similarly, again if we check, now see that if these are the all possible input sequences 0 0 0 0 0 1 0 1 0, then the present state a group of states, say S7 S8 S9, the next states are, these are actually the next states. So, and these are the output. So, see next states are S0 S0, S0 S0, S0 S0. Now, for this group of present state S11, S13, S14, obviously the input combinations are different, then again the same next states and same 0 0 outputs have been observed. So, if we combine, then we can write in this way that not 0 1 1 or 1 0 1, because already we have seen, see we have already seen that 0 1, if it is input sequence is 0 1 1 or 1 0 1, then it is S10 and next state is S0. For others, that actually this it is giving this the output behavior is same for other cluster of 3 present states S7, S8, S9 and S11, S13, S14. So, this is the two classes identified. This can be combined. This can be combined. This is the two classes identified. So, that is why it is written that it is written that not 0 1 1 or 1 0 1, this is not 0 1 1 or 1 0 1, means that cluster of 3 or better 2 cluster of 3 different present states. And one new rename states S7 dash has been given for the present state. Output is S0, or next state is S0, output is 0 0. So, there are two combined states we get, one is S7 dash, one is S10 dash. Okay. So, if we draw the final diagram, see, this is my reset state or the initial state. Now, say that if a 0, so it is a 0 input, 0/0 means this is 0. If input bit 0, then it is generating a output bit 0. So, 0 has come, this is 0. Then again 1 0, so bit pattern is coming 0 0. Then either 0 or 1, that means 0 0 0 or 0 0 1. In both the cases, it is giving output 0. So, it will be 0 0 0 0 0 1 or 0 or 1. That means, this branch is either 0 0 0 or 0 0 1 or 0 0 0 0, like that, 0 0 0 0 or 0 0 1 0, all these patterns will come 0 0 0 1 0 0 0 0 1 1, this type of all these things. Now, if it is a 0, then 1, then 0. So, see, this is a this is a 0 has come, now 1 1, but 0 1. So, 0, now it is a 0 1 1 0. So, this is a 0 1 1 0, then it will give a 1 output. So, this is a 0 1 1 0, and then it is a giving a 1 output. And if you consider that 1 0, so we consider 1 0 1 0, again this will be a 1 output, 1 0 1 0 1 0, this will be a 1 output. So, these are the two branches that we are getting a output 1, and remaining branches that it will be. So, this is a 1 0 1 1, it will be 0. Then if it is a 0 1 1 1, then it will be a 0, like that. So, it will be giving a this type of pattern matching. So, mainly this is a very straightforward algorithm. So, what we have done that the all possible inputs, the input output behavior and the state transition table we have created, and then we are trying to check whether any two row, at least any two row exist for that for any input combinations the output behavior is same. Then what we are doing, that these two, we are identifying these two rows that they can be combined, and then the present states are given or present state is renamed, and that can be a state. When we will be doing the state encoding, we will be doing the renamed state as encoded state. So, the state odd parity checker, this will be the S0, S1, S2, and these are the next states, and these outputs 0 and 0. So, these are, if we check this table, the parity checker, then we will be seeing that this table are no more, see, for no more combined, that S0, then again next state is S0, S1 output 0, for the S0, S2, so S2, that it is S2, S1 output is 0. So, these output behaviors are same. So, these S0 and S2 are combined and giving a name S0 dash. So, there can be two states S0 dash and S1, and for S0 dash the next states are same S0 dash, S1 0. So, what will be the thing? So, if it is these two are mapped, then if S0 and S2 are mapped, then the table will be that S0 dash, this is the present state, and next states will be S0 dash, S1 output will be 0, and this is S1. So, this is my present state, and this is S1, and now S2 becomes S0 dash and output becomes 1. So, see, for this can be easily combined and can be minimized. So, we consider two quiz questions for last two lectures, the lecture 24 and 25, that what is the difference between Moore and Mealy machine, because mainly we are designing some machines, and design a sequential system that recognizes 0 1 0 1 0 1 1. So, just like the today we have seen 1 0 1 0 pattern recognizer, instead of 0 1 0 we want 0 1 0 1 0 1 1, this thing should be recognized.